Okay, we're going to do a video now on this Year 10 maths investigation. If you are watching this, you likely have at least gathered the data or seen this investigation at this stage because we've covered it a fair bit in class. But this is the video to help you with some of those aspects. If you were away, what effectively we did was we went outdoors and we used inclinometers, which are these devices, to measure the angle of elevation from the eye level, so up to the top of the tree, in this picture, for example. And we also measured the distance horizontally from the base of the object we're looking at to where we're standing when we took the measurement for the angle. All right, so I'm going to demonstrate a problem similar to this. This is just a example problem. So we see we have a lady here. She's her eye level is 1.5 meters high. She's looking at the top of the tree and she measured a angle of 24 meters and she's standing, 24 degrees, and she's standing 60 meters away. So how do we go and work this out? Well, we can use right angle triangles to solve this. First of all, we're going to work out this distance from B to C. So that vertical distance there. Okay, so if we work that out, I'll use my pencil and I'll write on here. So I'll go BC. I'll call that X. All right. So how do we work that out? Well, I know if I got the angle of 24 and I know the base is 60, so that's still 60 meters here, and that's my X. All right, then I can use tan because I got opposite and adjacent. So the idea we would have tan 60. Whoops, not 60. Gotta get my angle first. 24 equals opposite X divided by 60. That's where the 60 goes. All right, and typing the 60 across, I could write this as X equals 10 24. Okay. Times by 60. So make sure you've got brackets in there. All right. You put that in your calculator. All right, so I got 60. Let's just do it the other way around. 60, 10, 24. Okay, so we've got the distance for X. So that's 26.7 is fine. I'll round it to that. So equals 26.7 meters. Now, is that the height? Well, not quite, because remember she's standing 1.5 meters high. So to work out the height, we need to add that on. So that would be 26.7 plus 1.5 equals, you would have 41, no, my bad, carrying the 1 too much. You would have 28.2 meters. So we've now got an estimate for the height of the tree by measuring the angle of elevation and the distance away from it, and also the eye level height as well. So this is the general way you're going to be working out these questions. If I was to simplify the whole thing, you could say something like the general formula would be height would be equal to distance times by tan of the angle plus eye level. Okay, so hopefully you've already gone and done some calculations like this. I'm going to shrink this down a little bit. Okay, so that's the general we're looking at. So that's an example question. That's not related to anything you've actually gone and done. I've just pulled that off the internet. And this is the general formula. The height would be the distance horizontally times by tan of the angle of elevation plus your eye level height. All right, if you do that, you're most likely going to get these sort of problems correct. If you've gone and found your own data, excellent. If you have not, on sector, you will find... Okay, see if I've got here. So that's the general assignment. All right. On sector, I have recorded some data from another group. All right, so we've got distance horizontal and angle of elevation to stem center. We've got the angle of the stack, the distance. I've got to show you how to do that on Google Maps in a minute. All right, we've got the gym, distance, angle of elevation, and a goalpost. So you can go and work out the estimates of the height, and there is the eye level height of the person who was recording all of this. So go and use those numbers and see if you can work these out. Now for the stack, we need to know the actual distance, okay? And that was very far away. So we were standing in the middle of the oval and measuring the angle of elevation, and but we weren't able to find the distance because it actually is pretty far away. So we're going to use Google Maps to do this. All right. So open up Google Maps and let's have a look at Port Pirie. Okay, so here's the map of Port Pirie. First of all, to find the stack, you need to get the satellite image. Okay, that's a little bit better. Okay, so our school is here, and the stack is over here, but we're going to zoom in and look for it. All right, so we've got a very tall object at the smelter. Okay, so we're going to find it. There it is. Okay, see that one with the big long shadow? Yeah, that's what we're looking at. What we're going to do is we're going to right click on that. All right, we're going to do measured distance. Okay, so we've put that there. Now we're going to go back and find the oval. All right, there is our school. I'm going to zoom in. All right, the terrace. Now we were basically standing in the middle of the oval. So we're going to left click over here, and there we go. All right, so most people got something in the lines of 4.1 or so 4.01, 4.02, something like that, approximately 4 kilometers. So you can go back to your distance. Now it's probably best at this stage you convert that to meters. All right, so you can take a picture of this. You can zoom out. Can you still see it? Yep. You can include a picture of this on your assignment, so you might just zoom out and you just take a picture. Okay, so the straight line distance from the stack to the center of the oval is about 4,000 meters if you convert to that. So we might even write that down somewhere, maybe on our notes. Can we do that? So no, we can't edit that. All right, but somewhere just write down. Nope. All right. Either way, on your assignment or somewhere, just take a note of that. And okay. Yep, Google Maps, find measure the distances, so you can take a note that that's 4,010 meters. All right, if you convert to meters. And then you can use that to calculate the actual height of this, or at least an estimate of it. You might find that's probably one of the more challenging estimates. All right, so I'm just going to leave that now, but just take a note of that when you go and do it. Okay, so what else do we need to do? So if you go through the assignment, just tick off everything as you're going through it. All right, so if you weren't there to actually do the measurements, okay, just use the ones I've given you. Okay, so now for the STEM building, we also have this diagram here. I'll help you to use that in a moment. So this is a scale diagram. You need to use this measurement tool because when we printed out these copies, they're not exactly scaled correctly to use your ruler to measure that. Right, so we have to use this measurement scale. What you need to do is you need to take this picture, including the scale, copy it into something like MS Paint. So you see, I've got a copy of it down here. All right, if you don't have access to Microsoft Paint because you're using an Apple or similar device, you can find something similar online. One such application here, paint.js.org. If you just search up online paint editors, you can usually find something like this. So if I go to this space, I can actually go and you see I've actually pasted using Control V. I've pasted part of that building. All right, but so you can more or less do whatever I'm about to do in Paint. You could do over here on paint.js.org, and this should work. So I think you've got everything we need. If you I want to paste that again. All right, can I? The main thing is you need to be able to rotate images. Okay, so if I went and highlighted that, what I just did there, come on, doesn't like that. Okay, let's see if I want to do it. I'll just see if it works. No. Angle. Well, at least you can rotate that. So you might need to rotate the image, and you might need to paste the ruler onto that. That would work. Okay. So for example, I've got that's the highest point in the building, and then I could just take if I do it the same way. Mind you, this is probably not going to work the way I like. You can take this and paste it on there, but I have a feeling my scaling is going to be off because I'm using two different pictures to do this, because I think I've zoomed this out a bit. All right, but in theory, uh, yeah, try to paste the whole thing in one go. And so here you go. So if I paste that, yeah, that's way too big. You notice that's been shrunk down. That's the same size. So you're gonna have to paste it all, and then maybe take another version of it and just make sure you've done it right. All right. There's probably another way you can do it. You can even look at the bottom, and you can kind of do it by counting pixels as well. But these two are not going to work. So I'm going to go over to my paint because I've actually got this already up. All right, so you can see here I've got the whole picture, including the scale. What I'm going to do, I'm going to zoom back in again. All right, then I'm going to take a section of this. I'm going to take this little section here. All right. So, all right. So what I'm going to be measuring to is from that highest point to the bottom of that thick line. So where the arrow stops to the bottom there. So I'm going to take that little section. I'm going to put it over here. All right. Now what I can do is I can rotate this 90 degrees. All right. And then I can use the scale to measure that. So I'll put this over here. I can start from 0. All right, so I might just mark on my thing where 50 is. I could use a line tool to do that. Okay, so line that up. That's too thick. Let's do a thinner one. It's extra thick because I zoomed in as well. Off by about a pixel, but I'm just going to leave it. Okay, so I put that there. I could then, so that's already 50 millimeters from there to there, and then can take this, move it along a little bit further. All right, and then I'll just measure the last little bit, and you can just keep doing this until you get there. So I could then go and line that up. That's very close to 80 millimeters because there's another 30 if you bring that down there. All right. Now, what you then need to do, okay, so after you do that, all right, the things you need to do, yeah, use, measure, height in millimeters. So you're measuring the height of the scale diagram. The scale is 100 times by 100. So you see on the bottom of the image, it says scale 1 to 100. You need to scale it up by 100 to make the real height. And then you also need to convert to meters. If you're going to get a very large number, so then you need to convert millimeters to meters, you divide by 100. Sorry, 1,000. Centimeters to meters is 100. Millimeters to meters is 1,000. So you'll be dividing by 1,000 to convert that to meters. I'm not going to give that away because you can measure it yourself and you can do the calculations yourself because that's part of your assignment. All right. Those are the main tricky bits, I think, for the assignment. All right, the rest of it, just make sure you're putting the effort into the different sections. You can go and see if you can find out how high the smelter stack actually is. Do a bit of research, ask around. Someone will know. And okay, and then just cover the rest of the assignment, cover all the parts from part A to part B or part C. I would like you to, if you've done work in your book, take a picture of it, crop it, put it into your Word document, and then put enough writing alongside it so it makes sense, so I can follow what you're doing in the assignment. So there's nothing that I have to guess. There's no mystery about what you're actually trying to do. All right. Okay, so the only part, if you're away, the only part you'd have to worry about that you couldn't do was actually going to do the measurements. That's fine because I've given you sample data anyway. So I think that should be fine. I'm going to leave the video here, and good luck.